हेलो।
हेलो। हेलो।
एक मिनट, वो स्ट्रीम शुरू है।
हम्म, इन लोगों को भेज दो अभी की बात
हाँ
है।
हाँ, भेज दो। हेलो।
हेलो।
एक मिनट, वो स्ट्रीम शुरू है।
इन लोगों को भेज दो अभी की बात
हाँ हाँ, भेज
है। तो पूरा मीट रहेगा क्या?
दो।
Hello, am I audible? Hello.
हाँ कंटिन्यू.
Hi. Hmm. So, today we will be having a lecture on STL and sliding window. Do you know about STL? What is it? Standard Template Library in C++. Anyone knows? So, it is a special library in C++, wherein we can use the data structures with abstraction. We don't need to implement them from scratch. We can just access them. So STL has three main components. It minimizes your efforts, and there are iterators. Iterators are like pointers. They are used to uh, locate the position of the element in your container. So let's see each one of them in detail. Uh, for every container, these four operations are the main ones. Like in every container, we need to insert, update, or delete, or search the element or traverse through it. So let's see one by one these operations in each container. So this is the vector. Like everyone have this was covered in the second lecture. I'm just showing this so you can revise it or glance through this. So for declaring and initializing a vector, we can do this by this. Like when we know uh, what elements we need to contain in the vector, if we don't know the vectors which we need to add in the vector, so we just declare it. We'll not initialize it with any elements. And if we know the size of the vector, so we can declare a vector of 10 size, like n size, and with initialize each element to 0. So this is declaration, and the access. I will be glancing through this since this has been covered. So elements can be accessed to subscript operator, and we have front function and back function in vector to get the first element and the last element. Uh, I can just run this code to if you want. The insert function is used to insert an element at some position in the vector. But what are we passing here? V dot begin plus 2. So V dot begin is the iterator. What is iterator? Uh, so we have majorly four iterators. Begin points to the first element of the container, and the end points to one past the last element. Like one element, if the end is at fourth position, it would point to the fifth position. And similarly, R begin points to the last element. It is used for reverse iteration. These two pointers. And Rn points to the one element before the first element. So it is used for reverse iteration. So and iterators are like pointers, but they are just given special names in STL. So this is the iterator. This is pointing to the first element in the vector, and plus two means that we want to insert the element at the second position of the vector. So our vector was this. We need to insert at second index. So at this index 25. So yeah, this is at the second index. This is what iterators do. Similarly, for the erase, we specify the index of the iterator of the index where we want to remove the element. So it is at the third index. We inserted and we remove at the third index 0, 1, 2, and 3, 30. 30 is removed. Yeah. In sort function also you use begin and end iterators. So this is vectors. Now let's get to accumulate and fill functions. Do anyone have idea about accumulate or fill? Please try to have this interactive. It would be quick. Uh, do anyone have any idea about accumulate and fill functions? Okay. So accumulate So let's see, the fill function is used to fill the elements in the array. Like in the first one, we saw like we were just declaring the uh, vector, like initialized vector with size n, like size 10 here, and initialized all values to 0. We could like do the same thing by fill function. Fill a dot begin, a dot end, the start iterator, end iterator, and the element with which we want to fill. So you would be thinking like, what is the difference between fill and this initialization? So suppose we are declaring the vector in the global space, like this has been declared in the global. So now if we want to fill this, we need to first resize it, or we could like push back elements. So that would be a lengthy code. Like we need to write 4 or 5 lines of code. This one just we need to resize the input of the size, what size it need to be in the main local space, and then we just resize the array vector to size n, and then we fill it. So it is done for vectors like which we initialize in the global space. It is initialized globally, right? Declared globally. And accumulate is used to get the sum of all the elements, like between a range. Here we are having begin to end. Like we could also have it like this. We want like vector v. It has 10 elements, 5 elements of with element 10. So if we want to get the sum of starting 4 elements, we can use this like from the first iterator to the last iterator. So it will get 4 elements. Let's see the sum. The sum should be 40, right? Yeah. So the size is the accumulate is giving the sum as 40. So it's not like we can only calculate the sum from the start iterator to the last iterator. We can get the sum between any two range, like any two iterators. So you can try using different iterators. Like here we are doing like last, second, last. So you can try this afterwards. Then okay. So do you know about lower bound and upper bound? Please, like someone reply like, do you can you switch on your mic and tell like I am not getting any notifications. You are pressing. Okay, so lower bound and upper bound are the functions like which we implement in binary search. So lower bound is to get the element. Yeah. So lower bound is helps us find the first position where the value is greater than equal to the given value. So what do I mean? If this is the array and I'm using the lower bound function and giving input as 50. So I will get the index of of the 50th element which is appearing first time, like greater than or equal to 50. This. And also the prerequisite is like it should be a sorted array for lower bound and upper bound functions. The array should be sorted. So here the if we are using 50, we would get the index as 0, 1, 2, 0, 1, 2, 3, and 4. So we would get the answer as 4. Let's run it with 50. Yeah. So we are getting the lower bound as fourth index, right? If you're having any doubt or not understanding anything, please like unmute your mic and ask. And what is the upper bound? Upper bound gives the position of the value which is greater than the given value. So lower bound is value less than equal to, and upper bound is value strictly greater than. So if we're having 50, getting for the upper bound of 50, we would be getting element, the position of the element which is greater than 50. What is that element in this array? It's 60, right? So what's the index of 60? 0, 1, 2, 3, 4, 5, and 6. Yeah. So we are getting the element index as 6. And what if we don't have an element present in the array and we want to find that in like so now please like you all answer. If we are not having 45 in the array and I'm calculating the lower bound, what would it be? You can make a guess too. Like please answer. Though the person who will be asking, he will be answering this. I will be giving extra points in the assignment. Please answer this. Wrong guess is also okay. Can you please unmute your mic and tell whatever chats you are doing? I am not able to see those. So please, if you're having any doubts, ask. Like unmute and ask. Okay. Mhm. What are you telling? Like 50 greater than? Okay. I am not understanding like this. Okay, so like, can you just give me the answer to this? Like, if we are finding the lower bound of 45, what will we get as an output? Others, you can also like fourth index 0, 1, 2, 3, 4. And for our upper bound, 3, 0, 1, 2, 3. Like for 45, we would get 3. Can you? No, it is not right. For what is upper bound? It is the element strictly greater than 45, right? So which is the element strictly greater than 45? It's 50, right? So we would get the this index. This is fourth index. If there is no element present in the array and we are finding its lower bound and upper bound, we would get the same index. And that index would be one element greater than the required element. And here also we are getting the iterators. The LB is a iterator, and uh, so we need to like to get the index. We are just subtracting from the v dot begin iterator. Like if we are getting the iterator to this point, and we're subtracting by this, so we get the index. If you want to print like what would be the iterator, how does iterator look like? You can see here. Like, I'm printing the iterator here. It won't be an index. Uh, Wait. Yeah, so it is an iterator. Like so we can like dereference it and get the index of that element. Do you have any doubt here? Like, why are you telling 3 and 4? Can you justify your answer? Yes. You can turn on your mic. LB3 and UB4 for what? 45. Uh, for 45, what does lower bound mean? Lower bound means the element which is less than or which is greater than or equal. Sorry, my mistake. Lower bound is the element which is greater than or equal to the given element. So 45. What is the element greater than or equal to 45 in this array? Yes, like everybody. 50, na? Right. So we will get the index of the 50 in the lower bound. Same in the upper bound, which is the element greater than 45. First element greater than 45. It's 50. So we are getting a same index, like 4 index. 4 and 3. What are you trying to say? 4 and 3. No. Upper bound will be 4 now. What is the definition of upper bound? The first element which is greater than the required element, right? So what is the first element greater than 45? So what is the first element greater than 45? It's 50, right? For the upper bound, first element greater than 45, it's 50, right? So it's index. So you get, do you agree? Or the largest element lesser than or equal to, no, sorry, that was my mistake at the start. It was greater than equal to this. I just did mistake. So upper bound is the first element greater than, lower bound is the first element greater than equal to the required element, and upper bound is the first greater element than the required element. So if it is 45, the lower bound would be the first element greater than or equal to 45. Let's see for 50, like you will be clear for 50. Sorry if I have a mistake at like lower bound, upper bound. By this you will be clear, like the lower bound of 50, the first element greater than or equal to 50. It is this, right? So we are getting as index 4. Upper bound, first element strictly greater than 50, 60, right? Index 6. We are getting 6. Everybody understood? If you all interact and keep your mic on, the lecture would finish quickly. Otherwise, it would extend. Like it's on you to do. So now we are like coming to structures like a map. So what is a map? So map stores the key value pair. It is used to store key value pair, and it is used for easy lookup. Like in case of unordered map, the time complexity of accessing each element is O of 1 on average. Worst case, it's O of n. Similarly, for searching in map, uh, insertion in map, and deletion in map. So in unordered map, like we store the key value pair, and this key value pair is random, like it's not in sorted order. Why is it in not sorted order? Because it uses hashing. And hashing, you might be, are you aware of hashing? Like you can read about it. I can share some link from GFG. The lecture now mainly we are focusing on the uses of this. If you want, I can explain at the end of the lecture. So the main four operations which we saw, like insertion, deletion, searching. Let's see this four operations in map. So map is declared like this: unordered map. Uh, then the data type of the key, data type of the value, and its name. And we insert the value. we can insert the value in map by two ways. By using the subscript operator, this is the key is 3 and value is apple. We can also insert using this, like mp.insert. This is the key and this is the value. The curly brackets here is just making it as a pair. Otherwise, we could also use it as make pair. So yeah, we can also use this to add insert element into the map. Then we access the elements by using this subscript operator, where we input the key, and also the at operator. Then for iterating the map, we use iterators. Like, so first let's see this. So we are using the iterators. This is the first mp.begin gives the iterator to the first element, right? And this is the iterator to the one element past the last, right? You agree? Like, why do we use product of primes in hash table? Why do we use product of primes? Uh, what- I'm not sure. Like, what are you telling? We can discuss this at the end, like end of lecture. So we use the iterators, and each iterator is pointing to a key value pair. So the first element of the iterator, like the iterator is pointing to some element, and that element has key value pair. And the first element in the key value pair is the key, right? So this gives us the key, and this gives us the value. Let's run this actually. Mhm. So yeah, so we are at the iteration here. So this is the key is two values cherry. So this is key value, and this is also another way of iterating over this. We use the auto keyword to get that element, and then we just use first and second, similar to this. Just here we don't need to explicitly declare the iterator, and then there is a find function in map through which we can get the iterator of the element, iterator of the key in the map. Like if I want to find the iterator to the key 4, like is key present in this key 2, key 1, key 3? There is no key 4. So we would get the iterator as mp.end. If there is no key present in the map, we would get the mp.end. Like if this is 2 and 3. So if we are searching for 4, we would first see, like we would start from first element to last element. We will iterate through all. So it would search like if 4 is giving to mp.end here. So it means there is no element 4. There is no element with key 4. That's why it's a key 4 not exist, not found. And count is also used to find like how many instance of key we are having. But this is an unordered map, and map stores only one element with elements with only one key. Like we cannot have two elements with key, say with same key. Like let's see, I tried to insert MP at 3 as say app. So it would replace the initial, update the initial one. We cannot have two elements with same key value in unordered map. For that, we would be having multi-map. So let's run this. So yeah, uh, we can see that the three indexes, the element with key 3 is having value app. and not Apple because we have updated it. So we cannot have multiple elements with same key. You understood this concept multiple? Okay, is a pointer or a value. It is a pointer. MP dot end is the iterator or a pointer to the element uh, one next to the last element. Do you understood that? MP dot end is an iterator, points the one past the last element. But is it null? No, no. It can be anything. It is just a pointer. Like so, we are just checking. Like, is it getting out of bound, out of the map, the which we have allocated? So iterators with a count count of like three. So in map, we can only have one instance, right? Elements with only one key. So the count would be either 0 or 1. If it's 1, like the element exists. If it is 0, the element does not exist. But the same thing would not be true in multi-map because we can have multiple elements with same key. So their count may be 2, 3, like anything. But in case of unordered map, it is only binary, 0 or 1. Then deleting the element in map. So we use erase function, and the input to the erase function can be the key or it can be an iterator. So let's see. Now we are using the iterator mp.begin. So what according to you would this mp.erase mp.begin be removing? Which element would be removed? Just tell me. It will remove the element at this iterator. This is our map. Which element will be removed? Yeah, remove first element. Like, can you say the key? Which key? Oh, sorry. Yeah, perfect. Because it is at first. So we are not considering the not considering the sorted key values. We are just seeing what is at the first position and just removing that.